of x and y, then I'm actually going to be talking about integrals. The numbers of random variables that I have will depend on the number, the numbers of integrals will depend on the numbers of random variables. Why do I have two integrals? Because I'm focusing on x and y, ds dy. If I have three variables, it's going to be ds dy dz. I can talk about multi-variable situation where I'm going to have the x1, the s2 up to the sn. Does that make sense? Okay, now I want to find, but let me tell you this. When I'm working with x and y that are discrete, here I'm using two-dimensional. X is going to have its own state space. Y is also going to have its own state space. Does that make sense? If I now want to find the probability of the joint occurrence now, should be ready to perform an antiderivative on the joint, but I'm going to have two integrals. Here now, I want to start with integrating the respect to y. If I'm going to start with respect to y, then this guy should be the range, the state space for y. You can see CD. But let me tell you this. I can write the y ds, I can write the s the y. Okay? And depending on the one I want to start with. Does that make sense? Okay. The other time, I show you how to find a marginal using discrete. What about, how do I isolate x? When I have a function of x and y, okay, where they are continuous. Oh my God. Look at this guy now. I got f of x, y. Okay, and I'm interested in f of x. Then I will integrate the joint with respect to the variable I'm not interested in. Does that make sense? Okay, I'm quickly going to give you an example here. And that very example we have to do with, okay, that's going to be the next one. Okay, now take a look at this. This is how we get the marginal. You integrate the joint with respect to the variable you are not interested in. Automatically, you're going to eliminate that particular variable you are not interested in. I'm going to give you an example now. Okay, a bank operates a drive-in facility and a walk-up window. Okay, a drive-in facility, a walk-up window. Oh my God, the two of them, they should be random variable because at different time, the numbers of customers that walk in varies and the numbers of customers that use a drive-in facility also varies. And we can look at this, we can view this as, working with a continuous random variable. Take a look at X. X, proportion of time the drive-in is used. Y, proportion of time the walk-up is used. Don't forget, the two variables, they can be jointly distributed because they covariate. They actually varies together. If the bank understand relationship between them, of course, bank will be able to make a very good decision, without wasting their customers' time. But you know what? A mathematician help us out to get to derive, a mathematician that has looked at the scenario, the occurrence of the event, I was able to come out with this joint function. You can see that, a joint function. You see that? And the range of s is 0 to 1 here, y 0 to 1. Do you know why we have 0 to 1 here? Because we're talking about proportion here. Does that make sense? Okay, now, the very first thing you need to do, if you really want to know whether this guy is a valid PDF, we need to show this. Okay, for continuous, you need to show that, I need you to take a look at something now. For f of x, for f of y, but for the joint. Does that make sense? If I want to show whether this guy is a valid joint PDF, then if I do this, I must get 1. If you don't get 1, whatever you're going to be computing from that will be very, very wrong. Now, take a look at this. Now, if you take a look at what I have here, okay, you're actually going to see that with that function, we can compute f of x, we can compute f of y, we can also compute a conditional function that I'm going to talk about. The conditional function is going to be, if I know the percentage of customers that are using drive, that are walking, can I determine the proportion that will drive in? Okay, that's conditional is coming in. But before going to conditional, let's look at the independent. Okay, you remember if you're talking about independent for discrete, it's just going to be the probability of the joint can be expressed as that. If I'm talking about continuous, it's going to be that. Now, what do I mean by independent? Independent mean if they are independent, it means there's no connection. Even though they varies together, okay, I don't need one to explain the other. That's what I mean. But in the moment they are not independent means they depend. If they depend, then we're going to be talking about this guy. Oh my God. We're going to be talking about conditional probability. If I want to get conditional probability now, if somebody said, what is the conditional probability of y given x? Then we're going to use this, which means, you have f of x, y, and you know how to derive of x. F of x is marginal. Does that make sense? So this is the formula. So what are we doing here? It's like we're more or less using this. We're more or less using this. You remember that? That's what we're using. That's exactly the idea we're using. Take a look at that. Now, others are examples that I reserve for what, that's what we're going to do in the lab. But you can walk through that. You're given this. Okay? I derive f of x to be this. Try that. That's a marginal. I derive f of y to be that. Try that. Then the moment I get f of x and f of y, I will be able to get the conditional. Go ahead.
Y, are you talking about like f derivative of x, or is it just like a different function than f?
Okay. When I say f of x, I just need a function of x, something that depends on x only. So here, if I want to get this guy, I will come here and integrate this with the respect to what? Y. Then, what is the range of y I'm going to use? 0 to 1. When you do that, you're going to get this guy. If I want to get f of y, right, what am I going to do? I'm going to come here, integrate this with respect to x. When I say integrate, I mean perform an antiderivative. And what range of x? 0 to 2. You will get this. Does that make sense? Now, the moment you get this, if I ask you conditional, it's just the ratio of that. I can ask the conditional of x given y or y given x. That's what I'm doing here. Look at that. Okay. I think the rest is... I'm going to continue from here tomorrow. We just have 3 more slides. I don't want to go over my time. Okay, is there any question?